This is the instructional video for lesson 1.3, which is solving by factoring. So we're going to try two different types of factoring. One type of factoring is going to be factoring using the rule factors of C sum to B. Okay, we've been talking about that in class. And then the other one is going to be the difference of two squares formula. We have tried that in class as well. So let's go ahead and take a look at some of the terminology that we need to know for this lesson. The first one here is quadratic monomial. A monomial is a quadratic expression with just one term. So some examples of monomials might be just x squared. Okay, or there could be a coefficient in front of that, like 1/2 x squared. We could also have a whole number coefficient like 2x squared. So it's still a quadratic, so it still has x squared, but it has just one term. There's no addition or subtraction here. All right, and then for the next one, a quadratic binomial is going to be a quadratic expression with two terms. So some examples of that would be, let's say, x squared plus 6 or x squared plus 2x. So it could be that there is a c and an a, but no b term. There could be an a term and a b term, but no c term. We could also have something like this, 3x squared minus 10, which is still two terms, no b term there, just a c. This time they were subtracting. That's the only difference there. Another example, 1/2 x squared minus 7x. So those are all called binomials. All right, the third term that we have here is quadratic trinomial, which is a quadratic expression with three terms. Often we call these polynomials because there's many terms. So it's a sum of three monomials. Even if we're subtracting, we can still call it a sum. So here's an example. X squared plus 11x plus 28 is an example. That's a polynomial or also called a trinomial. And then x squared minus 4x minus 2, another example of a polynomial. Okay, for the next thing we want to do is look at the example here. We want to recall that we can use FOIL to distribute, or basically we call that the double distributive property, to convert the binomials that you see here that are supposed to be multiplied together into a quadratic trinomial. So we want something that ends up looking like this out of our binomials that we're going to multiply together. So FOIL just stands for first, outside, inside, last. You'll recall that from some work that you did in class. So if I have my first terms are multiplied together, that's x squared. My outside terms are multiplied together, that's minus 6x. My inside terms, negative 4 and x. And my outside, so negative 4 times negative 6, which is positive 24. So I'm going to combine the things that I can combine. So in this case, these two terms have an x with them. So I'm going to rewrite this as a final answer as x squared minus 10x plus 24. I would like you to try B on your own. You're still using that same idea. First, outside, inside, last. In part 2 of our notes, we're going to factor, which means that we're going to undo the distributive property. So if we can go from having this, then that means, and we can find a way to get that to be a trinomial, then that means we can take a trinomial and get them back into two binomials. So factoring is simply undoing or doing the reverse of the distributive property. So we're undoing distribution. So if we took what we did in just that last example, we had x squared minus 10x plus 24. Okay, we did that by, doing the FOIL method, and we multiplied them all together, and we ended up with this. Well, that was the distributive property. So factoring just means taking our trinomial and going backwards and saying, well, what two numbers add to negative 10, and what two numbers multiply to positive 24? So if I take negative 4 and negative 6, those add to negative 10. And if I take negative 4 and multiply by negative 6, that multiplies to positive 24. And really that's all you're doing, is you're trying to find two numbers that multiply to C and add to B, or sum to B. So the next thing here in your notes says, to factor a quadratic trinomial, ask yourself which two numbers multiply to C and sum to B. All right, so if we write this out to the two binomials, we're looking for two values, m and n, that multiply to our number C and sum to our number for B. So if I was to FOIL this out, the x plus m times x plus n, I would end up with x squared plus, and we saw this on a video from Khan Academy if you were in class a couple of days ago. This should be an n, sorry. And m times n. So if I FOILed it all out, I'd end up with x squared plus m plus n times x. This is our b, really, if you think about it, that this m plus n is what b is. And then at the end, we need what numbers m and n multiply to bc. So we've come to some examples. I'm going to do a, b, and c, and then I'm going to ask you to finish up with d, e, and f. And if you notice here, one of those, d, e, or f, is going to be not factorable. So you won't find numbers that multiply to C and add or sum to B. All right, so my number here that I need to multiply to is -6, but add to +5. So if that's a negative value, that means that one of my numbers is going to have to be negative. So I'm going to try to factor this trinomial into two binomials. While I know that this is going to be x and x, I know one of my numbers is going to be negative and one of them is going to be positive because my C value is negative. So what numbers multiply to -6 but sum to +5? Well, I think a +6 and a -1 would multiply to -6 but result in 5. If I add 6 plus -1, that equals 5. So that works. All right, well, in part B here, I have a problem that looks like I have to multiply two numbers to -24 and sum the numbers to get +2. And if I do that with setting up my two binomials, again, I have a negative C value, so one of my numbers is going to be positive, one of my numbers is going to be negative that multiplies to -24. And I need a +2, so I'm going to use 6 and I'm going to use -4. Okay, so 6 times -4 ends up being -24. But if I add 6, this should be a plus sign, plus -4, that equals +2. So you can always do a little check to see that your numbers are going to come out correctly. So I had this answer for A, this answer for B. All right, so for my C problem, I have a 36 that I have to multiply to, and I have a 20 that I have to add to. So I went through and I said, well, the numbers that multiply to 36 are 12 and 3, 9 and 4, 6 and 6, 18 and 2, and then I stopped because 18 plus 2 equals 20. So I'm going to write this out, x plus 18 and x plus 2. All right, and so if I FOILed that out, when I FOIL out these two binomials, I should get 20x and a 36 for my C, because I know that 18 times 2 is 36, but 18 plus 2 is 20. All right, and that's what you're looking for in your problems that you're going to do down here. So you're coming up with two binomials, all right, for each of these. Of course, if D is not factorable, then you won't do that, but one of those three is not factorable. All right, write down any questions that you're not sure about. If something seems unclear, if you're getting lost, please make sure you ask questions in class. All right, the last part of this note set is going to be factoring quadratic binomials. We did this a little bit in class. We also were talking about perfect squares. Remember, perfect squares are those numbers that if you take 2 times 2, that equals 4, so 4 is a perfect square. 3 times 3 is 9, therefore 9 is a perfect square. So we wrote down all the different perfect squares that we know of. And, well, you know, up until a certain point. After a certain point, we probably won't get those numbers in our problems. But the factoring of quadratic binomials will happen when there's no b term, which means there's no bx term. Notice that there's just the x squared and then the constant term here. So when a and c are perfect squares and when the operator between them is a minus sign. Okay, so that has to be a difference. Remember, this is about a difference of two squares. So when we have a square as the a term and a square as the c term, then we can turn that into two binomials. One will have a plus sign in it, one will have a minus sign in it. All right, so a couple of examples that maybe we already talked about. X squared minus 49, that's going to factor into two binomials. X squared is a square, so we're just going to have an x for those. Remember, we have one plus and one minus, and then the square root of 49 is 7, so we're just going to have 7 like that. All right, and then another example would be, let's say 4x squared minus 25. The 4 is a square. Remember, we said that was 2 times 2. X squared is a square, and 25 is a square, so we can break that down into two binomials. One is going to have a plus, one is going to have a minus. The square root of 4 is 2, and plus we have the square root of x squared, which is just x. So 2x in this one. And then, of course, we have the square root of 25, which is 5. So there's our final answer. All right, so I'm going to do a few more problems here, and then you have 3 to do on your own. You're just making the quadratic binomial. Actually, it's a difference of two squares. You're going to use that to break this down and factor it. All right, so I have x squared minus 1. Again, just check and make sure that a is a square. Okay, and we don't have a number there, but it's really just 1, and 1 is a square because 1 times 1 is 1. And then we also see that here. So we're going to have x, because that's the square root of x squared. We need a plus sign and a minus sign, one in each binomial, and the square root of 1 is 1. So the idea here is if we went and did the FOIL method and we redid this, we would have the first and then the outside and then the inside and then the last, and we would end up back where we started. So if you cannot redistribute everything and make it back to where you started, then you know you don't have the two correct binomials. Now in part B, it looks like we have a 10, which is not a perfect square, and a negative 36, so this we cannot use the difference of two squares. I think probably I made an error on the note sheet. This should have been 100x squared, but just for the benefit of understanding that you can't use the difference of two squares if there's not a square out here. All right, and then part C here says 36m squared minus 49n squared. So that means we have a little bit more to this one because we have a square of a different variable over here. So the square root of 36 is 6. The square root of m squared is m. I'm going to put a plus sign and a minus sign. Actually, I probably should have spread that out just a little bit more, but I'm going to have to squeeze it in. So the square root of 49 is 7, and the square root of n squared is n. All right, so now I have to do my 6m here and my 7n here. So everything is really the same except for the plus sign here and the minus sign here. And that's how all of your answers should be when you end up factoring the difference of two squares. So remember that down here you're coming up with two binomials. You're basically taking the square root of a and c. Make sure you end up with one plus sign, one minus sign in each of your binomials. All right. If you have any questions, please make sure you write some down on your note sheet, and then I'll answer those questions in class.